Namaskar and a very good evening to all my friends here at HashLearn. My name is Uplav Kumar and today we are here for the second session on the chapter of electrochemistry. So today we are going to discuss mainly about the conductance and the Kohlrausch Law. So थोड़ा difficult pronunciations. I just hope that आप लोग समझ जाओ मैं क्या बोल रहा हूँ. Right. So I can see many people have already joined in. So good evening everyone. So I can see Dhruv, Vinayak, Arpit, Tamanna, Chandan, Smarnika, Priya, Vinayak, Radhika, everyone is here. So today we are going to, apart from the things for today's class, we'll also be discussing Drago's rule because I think Dhruv ने बहुत दिन से पूछा हुआ है कि sir what is Drago's rule, what is Drago's rule. So we'll be talking about that and we'll also be talking mainly about the conductance and what are the factors on which the conductance depends. Okay, so at any point of time अगर किसी को कोई doubt होगा तो obviously you know what to do. Just put in a comment and say what is your doubt and I'll try to resolve it. Fine. So now let us just start off with our class today. So I can see Rishabh has also joined in. So Divyansh is also here. Sahil is also here. Very good. I can see some new names also. Chandan, I think I'm seeing that name for the first time. So it's good. Just keep being consistent in our class and I'm pretty sure that आप लोग सबको बहुत फायदा होगा. Okay. Indrajit is also here. लगता है थोड़ा तो late करके सब लोग आएंगे इस class में, but it's not a problem. It's fine. Now let us just start off with today's class. But before that, a quick recap of the previous class. So first of all, in the previous class we did some numericals. We did some numericals in the previous class that was about the ionic equilibrium. Buffer solutions के ऊपर हमने कुछ numerical किया था. Then we talked about what is the difference between a metallic and an electrolytic conduction. Are both of them the same thing or what is the main difference between them? Then we talked about what is the process of electrolysis and what is the importance of electrolysis. So electrolysis का importance क्या होता है? Electrolysis is simply used to make a non-spontaneous reaction spontaneous. Fine. And then we talked about the preferential discharge theory जिसमें हमने पढ़ा कि if two or more cations are going to the cathode, which of them will get discharged? So that will basically depend on the electrochemical series and whichever is lower in that series, right? Then we talked about the Faraday's laws. So there were two laws of the Faraday जिसमें था basically कि the amount of deposition that is going to happen is dependent on the current that you are passing. Fine. The concept of conductance we are going to discuss more about that thing today. Okay. Now this was the question from the previous CPP in which most of the students are going wrong. And देखो इस केस में क्या है, अगर आपको ये क्वेश्चन नहीं आता है, it's fine. आपको ये क्वेश्चन को dimensional analysis से you can easily solve. See, we are talking about specific resistance. Okay, if the specific resistance of a solution of concentration C is R, so R I can say is resistance. It is specific resistance, right? Then its equivalent conductance. Okay, तो आपको पता हो कि resistance and conductance will be inversely proportional to each other. Akshay, I'm fine. Thank you. Mansi, Shubham have also joined in. So very good, very good. Chandan is also here. Good. So just look at the question. Then its equivalent conductance. So conductance का क्या value हो सकता है? Okay. So if you look at this thing, right? Equivalent conductance. Can I say that specific resistance it depends on the resistance, right? Specific resistance will depend on resistance. Okay. So equivalent conductance will definitely depend on conductance. Fine. So what are you seeing here? This C is what? This C is the concentration. Okay. And this R is what? It's the resistance. अगर आपका conductance आप देखो, तो if a body has a high amount of resistance, can I say that its conductance will be very less? Fine. Secondly, if a body has a very low resistance, I can say its conductance will be very high. So there is one relationship this, right? ये सबको पता होगा. Secondly, if I am talking about the conductance of a solution, we will learn in today's class also that if you dilute the solution, the conductance will be more. Okay, so the conductance increases with decrease in concentration. So I can say that conductance is also inversely proportional to the concentration. Fine. So overall, I can combine both of them and I can say that conductance is inversely proportional to resistance and concentration. Right. So there is only one option in which the RC is below. So that is why C will be your correct answer, right? So try to solve a question in any way possible. देखो एक बहुत बड़ा फायदा होता है MCQ questions का कि that no one is going to see how you got the answer, right? As long as you get the answer, right? So even if you are not able to solve it by the conventional way, try to use your mind and try to solve it from some other method. Okay? जैसे इस क्वेश्चन का मुझे नहीं पता था कि कैसे solve करना है, तो I just used my mind कि resistance किस पे depend करता है, conductance किस पे depend करता है, and then I found the relationship and through that I got the answer. Fine. Okay, now let's talk about what we are going to do in today's class. So first of all, I am going to talk about the Drago's rule. So ज़्यादा कुछ we are not going to discuss about it because इसका बस एक mention किया जाता है whenever we are going to talk about the p block elements. Then you're going to talk about the factors affecting degree of ionization. So what are the factors on which the degree of ionization will depend? So degree of ionization is also known as degree of dissociation. Okay, so don't think that they are different. They are different, but in this chapter we'll be considering them as the same thing. Okay, then you're going to talk about the ionic conductance, then electrolytic conductance. So ionic and electrolytic conductance are similar, but we'll learn the difference. Okay, then we are going to see what happens to conductance at infinite dilution, because हमने just कहा कि if the concentration is less, the conductance will be high. So if I make the concentration so low that it is almost an infinite dilute solution, then what will be the conductance there? Then we are going to look at the Kohlrausch Law, how we use it to solve numericals, and then this is a theory which is also known as a theory of strong electrolyte. Okay, so we'll be discussing all of this in today's class. So now let us start off with today's class. So Tirth is also here, Priya is also here, very good. Now let's everyone just focus here and try, just tell me at any point of time if you have any doubt. Okay, so what is the Drago's rule? So देखो Drago's rule का existence तब आ रहा है because when you are talking about something like suppose NH3, okay, so everyone knows this thing that in the VSEPR theory we talked about कि if I am talking about N in NH3, because जो shape होगा N का वही shape होगा molecule का, fine. So this N has 3 bond pairs, right? This N has 3 bond pairs and it has 1 lone pair. So overall I can say that it has 4 electron pairs, and we learned that whenever the central atom has 4 electron pairs around it, it will always go into the shape of a tetrahedral, right? So it should go in the shape of a tetrahedral. Now in tetrahedral the angle is how much? 109.5, right? But because NH3 has 1 lone pair, so the repulsion will be more, and because of which this angle will reduce to 107.5. Okay, so this is what we see for NH3. If I am talking about H2O, तो H2O में 2 lone pair होगा, 2 bond pair होगा. So this should also go in the shape of a tetrahedral. So this should also have an angle of 109.5, but because there are 2 lone pairs, so there will be much more repulsion here. So the angle for this is 105, something like this. Okay, so this is what we are expecting according to the VSEPR theory. But when you look at something like PH3, right? आप बोलोगे PH3 में भी एक lone pair है, PH3 में भी 3 bond pairs है. So the shape of NH3 and the shape of PH3 should be exactly the same, or at least similar, right? So what we see in case of PH3, we see that the bond angle is around 93 degrees. How is this happening? It should be around 109.5, but we're seeing that the bond angle is 93 degree. So to explain this sort of shape and this sort of phenomena, Drago's rule was formed, which explains what is happening. Okay, so I want just everyone to be focused here. The rule is applicable when the central atom has, okay, it has 1 lone pair and belongs to the 3rd period or lower. So if your central atom is in the 3rd period or the 4th period or the 5th period and has 1 lone pair, then this rule will be applicable. Second point, the EN value of the neighboring atoms is less than 2.5. I am pretty sorry, it should be 2.1, but 2.5 almost similar, don't worry. So what it means that suppose I am talking about something like sulfur. Okay, now sulfur is suppose bonded to A, B, C and D. कहीं double bond भी होगा तो उसके बारे में ध्यान मत दो अभी, right? So what happens if the electronegativity value of the neighboring atom, अगर इनका electronegativity value is less than 2.1, then only we'll be using the Drago's rule, right? So if I have a very electronegative atom here, suppose I have an F here, then Drago's rule will not be applicable. Third, you can calculate the number of hybrid orbitals by using this formula. अब देखिए formula क्या है? This is the valence electrons. How many valence electrons are there? This is the number of monovalent neighboring atoms. याद करो monovalent. It's not divalent or trivalent. So if your central atom has an oxygen atom around it, we won't count that because वो divalent atom होता है. Fine. Now this is the charge on a cation, and this is the charge on anion. Right. That divided by 2 will give you a number of hybrid orbitals. Fine. Now देखो क्या हो रहा है. If no hybridization means, अगर आप suppose करें इस formula को use करो and you find that a number of hybrid orbitals is 0. Right, let's try to find it. Okay, so if I am talking about something like suppose PH3, okay, in PH3 can I say that I have 5 valence electron? So I can put this as 5. Now M is the number of monovalent atoms. कितने monovalent atoms है? 3. So that plus 3, fine. Minus C, that is the charge on a cation, plus A. So basically ये दोनों similar होके कट जाएगा. So what we find in this case? Okay, what we find in this case that in case of something like PH3, because the bond angle is something like 93 degrees, right? It basically indicates that there will be no hybridization happening. Okay, about this formula, ab isko rehne do because we are not going to use this formula anywhere, but try to understand the final point, which is the most important point. Look what is it is written. If there is no hybridization, it means the bonding will happen through pure atomic orbitals, like in pH3, which has a bond angle of approximately 90 degree. Okay, so what it's trying to imply is that suppose I am talking about carbon. Okay, so carbon mein kya hota hai? I have 2s that is having 1 electron and I have 2p that is having 1 electrons each. Okay, so what happens in this case when it's going to make a bond with suppose H, the 4 orbitals they hybridize to give you 4 sp3 orbitals, and because all of these 4 are identical in all aspects, so it will go into the shape of a tetrahedral, right, in which the angle is 109.5, right. But if I am talking about something like a pH3, in pH3 there is no hybridization happening. Now because there is no hybridization happening, so P ka kya hota hai formation valence shell, it is 3s2 and 3p3, right, it's like this. So because there is no hybridization happening, can I say that the px, the py and the pz will simply make bonds with something like the 1s of H, right? This is what is going to happen because we are assuming that there will be no hybridization. Agar hybridization nahi ho to kya kya bonds ban rahe hai? Can I say that one bond is a px 1s bond, another bond is a py 1s bond, and the other is a pz 1s bond, right? So because all of these three are mutually perpendicular to each other, the bonds will also be mutually perpendicular to each other, right? So what happens? Because of such reasons, we expect that pH3 will have a bond angle of, it will have a bond angle of approximately 90 degree, right? So it actually has a bond angle of 93 degree. So if you go down in the group 15 halides or the group 16 halides, you will see that something like an H2S has a bond angle of around 92 degree, and if you keep going down, this number will approach to 90 degree. So this is why it is very important, because agar aapko ek question mila ki what is the bond angle order of subgroup 15 halides, right? So it is something like NH3 ka more than pH3 ka more than the next one, the more than the next one, and so on, right? Similarly, I can write for H2 also. H2 has more than H2S, which has more than H2 selenium, I think, and so on, fine. So I hope that this thing is clear. If anyone has any doubt in this, please tell me. Okay, I hope that this thing is clear. Iska zyada implication nahi hai, but just try to understand. We are getting an angle of 90 degree because the bonding is happening through pure atomic orbitals and not through hybrid orbitals. That is why Px, Py and Pz, they are almost 90 degrees to each other. That is why the bond angle will also be 90 degrees to each other, fine. I hope Dhruv, this thing is clear now. अगर आपको कोई और डाउट हो, उसमें कुछ क्वेश्चन बनाने में आपको डिफिकल्टी हो, प्लीज टेल मी एंड आई विल बी एबल टू सॉल्व दैट sometime later. Now, what are the factors which affect the degree of dissociation? Okay, so suppose I have something like an NaCl, okay, or something I have suppose an HCl, or suppose I have an H2, okay. So all of these three are compounds, fine. Now if I dissolve all of these three in water, which of these three will dissociate very easily? I can say that this will dissociate almost completely, this will also dissociate to some extent, but इसमें dissociation होगा ही नहीं, right? So if you are talking about the degree of dissociation, the degree of dissociation, that is alpha, it is dependent on, it depends on ionic nature. It depends on ionic nature. तो अगर आपके मॉलिक्यूल में ionic nature ज्यादा है तो उसमें dissociation ज्यादा होगा, अगर उसमें ionic nature बहुत कम है तो उसमें dissociation बहुत कम होगा. For example, this is a completely ionic compound, so this will easily dissociate. This is a polar compound, I can say it's a polar covalent compound, so it has some ionic character, so इसका भी dissociation हो जाएगा. But if you look at something like H2, H2 is completely non-polar in nature, right? It has zero polarity. If it has zero polarity, I can say it has zero ionic character, right? Because it has zero ionic character, its alpha, that is the degree of dissociation, will also be almost zero. So if you dissolve something like a non-polar compound in water, it won't dissociate, fine. So that is how the nature of solute, what is the factor of that. Now nature of the solvent, if your solvent is a very good dielectric medium, then it will split up the ions very easily, okay. So the degree of dissociation, again it depends on the dielectric value. depends on the dielectric value. So if I am talking about something like water का dielectric value is around 90. Okay, if I am talking about something like CH4, इसका dielectric value is something around 30, right? So because of this reason, if you dissolve an ionic compound in something like H2O, the dissociation will happen very easily, but if you dissolve that in something like CH4, then it won't happen, fine. So the degree of dissociation depends on the dielectric value. Higher the dielectric value, higher will be the degree of dissociation. Next, how does it depend on dilution? So देखो, if I suppose I am talking about 10 molecules of HCl and suppose I am talking about 5 molecules of water, okay, I have a solution which has 10 molecules of HCl and 5 molecules of H2O. Now remember one thing, whenever I want HCl to dissolve, right, what happens? HCl plus H2O, HCl plus H2O will give us H3O plus Cl minus. So can I say that for HCl to split, I need water, right? For HCl to split, I need water, right? So if I have suppose 5 H2O and I have 10 HCl, can I say that इस case में dissociation बहुत कम होगा, right? Now instead of 5, if I have 50, I have more water molecules, right? So in this case, can I say that the dilution will be the dissociation will be more, right? Hence I can say that the degree of dissociation, it will increase with dilution. So the more diluted your solution is, the degree of dissociation will be higher, fine. Arpit, you don't need to know the dielectric value of all of them. Just remember the dielectric value of water, that is very important. And most of the universal solvents, most of the solvents will have a dielectric value of less than what is of water. Remember one thing, what is called a universal solvent because it has a very high dielectric value. Okay, so there is no need to remember all the dielectric values. So that is how I can say that the dilution, it will increase the degree of dissociation. So degree of dissociation increases with dilution, fine. So if your solution is more concentrated, उसका degree of dissociation कम होगा. If you increase the dilution, then उसका degree of dissociation बहुत बढ़ जाएगा, fine. Okay, what about the temperature? So देखो, what I am talking about, we are talking about dissociation, we are talking about a bond getting broken. Okay, so you should know one thing, whenever you want to break a bond, you need to supply energy. Whenever a bond is made, energy is released, fine. Now what we are talking about, we are talking about a degree of dissociation. Now degree of dissociation means that the molecule will split up, right? So can I say that the more the temperature, the more easier it will be for the molecule to split up, right? So I can say degree of dissociation increases with temperature, fine. Does anyone have any doubts still here? I hope that no one has any doubts. Now what do you mean by ionic conductance? So देखो, suppose I dissolve something like an Na plus and Li plus in water, right? The first thing that you should know that suppose I am dissolving NaCl, okay, the NaCl will split up to give Na plus and Cl minus. Now if there is only Na plus and Cl minus in water, what will happen? They will again combine with each other because उनके बीच में एक electrostatic force of attraction होगा, right? But what happens whenever you dissolve something like this in water, it gets surrounded by the negative part of water like this. It gets surrounded by the negative part of water like this, right? So now you cannot think that the Na plus is only this much. The Na plus is now almost this large, okay? So whenever you dissolve an ion in water, उसका खुद का radius doesn't matter as much this matters, okay? So if I am talking about something like Na plus, Li plus, okay, K plus, and suppose I am talking about the next also. So देखो, this is the order of increasing radius, fine. But when you dissolve these things in water, because देखो एक चीज समझो, सबके पास एक charge ही है, okay. Li also has one positive charge, Na also has one positive charge, and K also has one positive charge, okay. But I can say that the lithium is much smaller. Because lithium is much smaller, I can say it will have a higher charge density, and because it has a higher charge density, this process will be much more effective in case of lithium, okay. Because of which what happens, the aqueous solution में जो उसका radius होता है, that is the ionic radius, that thing of Li is the highest. So Li plus has the highest radius, then you have K plus and so on. So I think we have here cesium and then you have francium or something, right? I think I am missing something, but don't worry, उसका ज़्यादा फर्क नहीं पड़ता है, right? So when you are dissolving this thing in water, even though Li is very small, but because it has the highest charge density, the solvation in case of Li will be very high, and hence the ionic radius will be in this order. Now because the ionic radius of Li is highest in water, the conductivity of Li will be lowest. Okay, so what is the order of conductivity? The order of conductivity will be Li plus has the lowest, then you have Na plus, then you have K plus, then you have Cs plus, and so on. Ashish, you are talking about hyposolution. What do you mean by hyposolution? Because hyposolution वैसा solution जिसका एक concentration कम होता है, right? But how is that coming here? I am not sure. Yes, Radhika, I just missed rubidium, so you can just fit it there. Okay. So I hope that it's clear that why is the order of conductivity like this, right? If anyone has any doubt in this, please tell me. Just try to understand. I'll explain this again if you want. Okay. So this is suppose the Li, right? Now in Li, the OH2 will bond like this. And whenever I am talking about conductivity, I want the charged particles to move. Okay, I want the charged particles to move, right? So what happens if I want the Li plus to act as a conductor, right? The ion should move from the positive plate to the negative plate, or sorry, from the negative to the positive plate. तो उस केस में क्या होगा? This entire thing has to move. Okay, now because Li plus has a very high charge density, a lot of OH2 molecules will surround it. Okay, compared to this, if I am talking about cesium, तो cesium का देखो size थोड़ा बड़ा होगा, fine. But in this case, the charge density is lesser. Because the charge density is lesser, fewer molecules will surround it now. Right. Now because of this, I can say that the size of this thing is lesser than the size of this. Now इसका size अगर ज़्यादा है, then it will face more obstruction. Because it will face more obstruction, इसका conductivity will be lesser than that of cesium. Right? Radhika, see, you cannot correlate it with the concept of hydration energy, because hydration energy is the effectiveness of कितने solution हो रहा है, right? It doesn't tell you much about the size of solution. Okay, so yes, you can talk about it कि जिसका hydration energy ज़्यादा होगा उसके केस में linkage ज़्यादा होगा, but don't use it as a direct relationship. Okay, so I hope that this thing is clear. Why does the Li has a lower conductivity than cesium? If anyone has any doubts, please tell me. Now let's see what is the effect of pressure and temperature on ionic conductivity. So Radhika, I talked about this thing in the previous class, right? Ki the resistance increases with increase in temperature. Now see what is happening and why it is happening. Now if you increase the temperature, right? I am talking about the ionic conductance. Now if you increase the temperature, if temperature is increased, can I say that the viscosity of the water will decrease? What is viscosity? Viscosity is basically the friction between the different layers of water, right? So if I increase the temperature because of larger movement, can I say that the viscosity will decrease? I can say that the viscosity will decrease now. Now, if the viscosity decreases, can I say that the solution has become less dense now? Right? I can say it has become less dense. Now because it has become less dense, can I say that the conductivity will be more? Conductivity will increase, right? So that is why if you increase the temperature, the ionic conductance will increase. Okay. So if you have doubt with this, please tell me. Now what happens with pressure? Now suppose I have this solution here which has water in it. Okay. Now what happens, suppose I am pressing it from the top. Okay. Now when I am pressing it from the top, can I say that the different layers are rubbing against each other, right? Now if you press it, can I say that the viscosity will increase? So if the pressure increases, I can say viscosity increases. Now if viscosity increases, what will happen to conductance? Conductance will decrease. So the conductance will decrease. right? So that is how the ionic conductance, it varies with temperature and pressure. Increasing the temperature will decrease the viscosity. If viscosity is less, conductivity will be more. Fine? Yes, Rishabh, exactly. Viscosity is what is acting as an opposing force for the movement. Okay, so viscosity कम होगा तो conductance ज़्यादा होगा. Fine? So I hope this thing is also clear with everyone. Now let's talk about a more generic concept, that is conductance. Okay, so what is exactly conductance? To understand conductance, let's first understand what is resistance. Okay, so resistance R is equal to rho into L by A, right? Now बहुत simple meaning है, rho is the resistivity, and this depends basically on the nature of the particle. Okay, so if I am talking about suppose this thing, or if I am talking about water, right, दोनों का resistivity different होगा, hence the resistance they offer will also be different. Fine. So I can say that this is the resistivity. Now if I have, अगर मैं देखना चाहूँगा इन दोनों बीच में resistance कितना है, तो suppose that comes x. If I increase the length, can I say that it will face more obstacle now? So that is why R is directly proportional to L. If you increase the cross section, the resistance that you will feel will be less because of ज़्यादा area जाने के लिए. So that is the relationship between resistance and resistivity. Okay, so I can write this as rho is equal to R into A by L, right? Now if I take if I basically take 1 by of the entire thing, I'll get something like this, 1 by rho, I'll get 1 by rho will be equal to 1 by R into L by A. I'll get this equation. Now 1 by rho is basically 1 by resistivity, so this thing is called specific conductance, right? This is called specific conductance and it is denoted by K, a smaller K, but don't worry, आप लोग समझ जाओगे वो. 1 by R or 1 by resistance is what we call as 1 by resistance is what we call as conductance, right? And this L by A is what we call as the cell constant, right? So hope that everyone is clear with the specific conductance. So I'll just write it here. So K is equal to G into cell constant, right? What is K? K is the specific conductance, which basically depends on the nature of the material. G is the conductance that is being offered, and this is the cell constant. Okay, so you can get a formula from this about this कि आपको conductance पता है, specific conductance पता है, to find the cell constant. Okay, so you'll get questions like this from this. Yes, Rishabh, conductance means the ability to pass electricity. Conductance, see देखो, resistance क्या होता है? What is the obstacle you are facing? Okay, so if I am saying that a solution is highly conducting, it basically means that the resistance it is offering is very low. Okay, so I hope this thing is also clear. Now देखो इसका एक दो expression होता है which you might be finding it useful for solving a numerical. बहुत simple सा चीज है. K of electrolytic solution. Okay, so if I am talking about suppose an NaCl in water, so I can say that this is NaCl plus H2O का conductivity. That will be equal to the conductivity of the electrolyte, that is NaCl, plus conductivity of water. तो basically simple एक addition हो रहा है यहाँ पे. Second thing, if you mix V1 volume of a medium K which has a specific conductivity of K1 with V2 volume of a medium which has a conductivity of K2, then the resultant solution will have a conductivity of Kr. And how do you find it? You can find it from this formula. Fine. So simply आप ये formulas use करो and you'll be able to solve your questions. Now let's talk about something that is very important, and that is the equivalent conductance and molar conductance. So just try to read through this thing and आप try to understand कि आपको कुछ समझ में आया कि नहीं आया. Okay, read what it is. The conductance of all the ions produced by 1 gram equivalent of an electrolyte in a given solution. Now what do you mean by 1 gram equivalent? 1 gram equivalent means it has an equivalence of 1. Okay, so what it means, suppose I am talking about something like HCl. Okay, so HCl is, if I dissolve 1 mole of HCl in water, if I dissolve 1 mole of HCl in water, I can say it has a molarity of 1. There's a molarity of 1. Now because HCl has an equivalence of also 1, I'll say its normality will also be 1. Right? Now what is normality? Normality is the number of equivalents divided by volume. Okay, so what is basically the equivalence? Equivalence is simply, if I am talking about an conductor, right? For a conductor, the charge is what we are going to look at. Okay, so if an ion has one charge, okay, then I say that it is equivalent to one conductor. Fine. So what is written here? The conductance of all ions produced by 1 gram equivalent of an electrolyte in a given solution. Okay, so I can say that the conductance of an ion produced by one normality solution is what we call as the equivalent conductance. Fine. Now what about the molar conductance? बस एक definition की बात है. There is not much difference in both of them. See what is written here. The conductance of all the ions produced by ionization of 1 gram mole. Okay. So because you are talking about molar conductance, तो इस केस में molarity आ जाएगी. Because you are talking about gram equivalence, इस केस में normality आ जाएगी. Right? So the conductance of all the ions produced by ionization of 1 gram mole of an electrolyte when present in VML of solution is called molar conductance. Fine. तो इसमें I hope कि किसी को कोई doubt नहीं है definition में, बहुत simple सा चीज है. Now let's find a relationship between both of them. Okay. Now let this be denoted by this and let this be denoted by this. Okay. Now this is equal to K into volume. This is the expression that we have. Okay. And this is also equal to K into volume. Now this is what? This is the volume which has one equivalence of the electrolyte. Okay. So can I say that this has a normality of 1? Right? Normality of 1. Now what is the formula of normality? Normality is equal to number of equivalents divided by volume into 1000. Right? Now can I say that the number of equivalents we are looking for 1? We are talking about 1 equivalence. So I can rub this thing and write 1. Okay. Now if I want to find the value of V क्या होगा? V will be equal to 1000 by normality. Right. So can I use that thing here? I can write it, this is equal to K into 1000 by N. So this is another expression for the equivalent conductance. Similarly, in this case, what is V? In this case, V is the volume which has 1 mole of the electrolyte. Okay. So in this case, I can say molarity will be equal to 1 by V into 1000 because I am looking for 1 mole only. So what will V be here? V will be equal to K into 1000 by molarity. So this is another expression for the molar conductance. Right? So you will be using these things to solving numericals. Okay. So don't worry. Now if I want to find a relationship between them, let me divide both of them by each other. Okay. So delta this by this will be equal to, can I say M by N, the molarity by the normality, right? Now what is normality? आपने पढ़ा होगा पहले चैप्टर में, normality is basically molarity into N factor. So I can write this as is equal to molarity by molarity into N factor. So M and M will cancel. So what is the relationship between them? This is equal to, I can write the molar conductance is equal to N into the equivalent conductance, where N is what? N is the number of equivalents. So for an electrolyte, the number of equivalents is basically equal to the number of the total positive charge or the total negative charge. Fine. So if I am talking about something like NaCl, NaCl has an N equal to 1. If I am talking about something like an Al2SO4 whole thrice, in this case N will be equal to 6. Fine. So that's all about this thing, right? Now it's time for the contest, and this is the question from the previous contest. Okay. And the winner of the previous contest is Jyotsna. So congratulations Jyotsna, you will be getting a free add-up session that will be credited to your account, and the winner of this and the correct answer of this was sodium chloride. Okay. So this was the previous contest. Now it's time for today's contest, and I want everyone to be ready. The question for today's contest is this. Vinayak, I'll solve one question today because our time nahi hai, but I'll solve one question today. Don't worry. Okay, so this is a type of question that you will be facing. So just try to solve this. बहुत easy question है, अगर आप लोग को समझ में आया होगा then I want everyone to attempt. Not only attempt, बहुत easy है तो I want everyone to give a correct answer. Okay, fine. I can see many people are commenting now. Okay. Okay, fine. Five more seconds. I want everyone to just make an attempt. Okay, good. I can see many people are given their attempts here. Okay, so I think that's it. Now let us move on to the second part now. Okay, now what is the concept of infinite dilution? So देखो, we discussed that alpha is dependent on dilution. If you increase the dilution, the degree of dissociation will increase. If the degree of dissociation increases, can I say that the conductance value will also increase? Because ज़्यादा ions होंगे तो ज़्यादा conductance होगा. So what happens if you take something like molar conductivity? Okay, now if you take this thing depends on the conductance. Fine. So this thing depends on the concentration. So if you keep on decreasing the concentration, can I say that this thing will go up? Right? So what happens at infinite dilution? At infinite dilution, we can assume that the concentration is 0. Because अगर dilution infinite है तो concentration 0 हो जाएगा. Now at this case, the value of the molar conductance or the value of the equivalent conductance is what we call as infinite value, right? Because this is a limiting value, इससे ज़्यादा is not possible. Okay, so if I am talking about something like the value of suppose NaCl at C concentration, right? तो इसका कुछ value होगा obviously, but if you decrease the concentration, if you go towards infinite dilution, the value that I'll get, right? This will be greater than this value, right? So this is called the limiting value of the conductance, and this is achieved at infinite dilution, right? Okay, so infinite dilution में ज़्यादा कुछ इसमें concept नहीं है, बस इसमें main चीज़ यही है कि if I am talking about suppose strong electrolytes and weak electrolytes, दो केस हमें देखना है, strong electrolytes and weak electrolytes. तो one thing that you should know that for weak electrolytes the concentration से बहुत ज़्यादा impact पड़ता है. Okay, so if I can draw a graph like this such that this is concentration and this is conductivity. Okay, suppose this is conductivity, so I'll just write as this. Now for a weak electrolyte at a very high concentration the conductivity is very low, something like this. Okay, so if you decrease the concentration, the conductivity will keep on increasing till it reaches a value like this. Okay, so this is basically the graph for a weak electrolyte. But if I am going to talk about a strong electrolyte, so strong electrolyte क्या होता है? It almost completely dissociates. Fine. So in that case what happens? Its conductivity is already very high, and but it was थोड़ा और बढ़ेगा, right? So like this you can get a limiting value when you take the concentration equal to 0, right? But that thing cannot be done with a weak electrolyte because it will go towards infinity like this. Fine. So that is how you can use a graph to understand what happens to a strong electrolyte and weak electrolyte at infinite dilution. So देखो, this is a strong electrolyte, and you can see that even at higher concentration it has significant amount of conductivity. Okay, but if you decrease the concentration, the conductivity will increase. For a weak electrolyte, what happens? Initially at high concentration the conductivity is very less, right? But if you keep on decreasing the concentration, its value will keep on increasing, right? So something like this. So that is how you should understand the graph. अगर आपको कोई इसमें doubt नहीं होना चाहिए. Okay. Now what is the Kohlrausch law? तो देखो law बहुत ही basic सा चीज है, इसको आप complicate मत करो. Just try to think of it as a mathematical theory. Okay. What it says, just listen. At infinite dilution, when dissociation is complete, each ion makes a definite contribution towards equivalent conductance, because eventually क्या हो रहा है? Each and every ion will move, right? So I can say each ion makes a definite contribution towards equivalent conductance, okay, of the electrolyte irrespective of the nature of the ion, with which it is associated, and the value of equivalent conductance at equivalent dilution for any electrolyte is the sum of the contribution of the constituent ions. तो ये चीज बहुत सिंपल बात बोल रहा है, that suppose I have A, right, and A has suppose 10 ions, then the conductance of A will be equal to the conductance of the 10 ions added, basically. Fine. So suppose this is the first ion, तो उसका conductance plus the conductance of second plus the conductance of third and so on. So this is basically the Kohlrausch law. इसमें I hope किसी को कोई doubt नहीं है, बहुत ही simple सा law है. It simply says that if I suppose NaCl, okay, so the conductance of NaCl will be equal to conductance of Na plus plus conductance of Cl minus, right? So I hope this thing is clear with everyone. So I can write this thing as the conductance of an electrolyte is equal to the conductance of the cation plus the conductance of an anion. Fine. Does anyone have any doubts till here? Please tell me, because we will be solving a numerical about this. Okay. So does anyone have any doubt? Fine. Okay, fine. Thank you. Now, suppose I am talking about again degree of dissociation. Okay. Now, if I talk about infinite dilution, can I say that at infinite dilution, okay, at infinite dilution, can I say that the degree of dissociation will always be 100%, because बहुत ज़्यादा solvent है तो almost everything will dissociate. So I can say at infinite dilution, degree of dissociation takes a value of unity. So that is equal to 1, right? So what happens at this case, I can say that the value of the molar conductance is equal to the value of the molar conductance at infinite dilution, right? So what happens? This is equal when I am talking about infinite dilution. Okay. Now, if I am not talking about infinite dilution, can I say that this delta M, it will depend on alpha, right? Because अगर degree of dissociation कम हो जाएगा तो molar conductance भी कम हो जाएगा. So from this we get a very important equation which says the degree of dissociation is equal to the molar conductance at a specific concentration divided by molar conductance at infinite dilution. Okay. So you might get to use this formula to solve numericals. Okay. So basically I just wanted to give one formula again. So what happens, suppose I am talking about H, something like an AB. Okay. So what happens to AB? It will give you A plus and B minus. Now if I assume that this is a weak electrolyte, it means इसका degree of dissociation बहुत कम होगा. So initially this is suppose C, this will be 0, this will be 0. After some time it will become C into 1 minus alpha, this will become C alpha, this will also become C alpha. So I can write the value of K now. So it will be C square alpha square divided by C minus 1 minus alpha, right? Now from the previous case, I know that alpha is equal to, right? So if I put this value here, I will get an equation that will be K is equal to C M square divided by, ये आप खुद से भी निकाल के देख सकते हो, यही आना चाहिए आपके पास भी, माइनस. Okay. So this equation, with the help of this equation, if you know the equilibrium constant and you know the concentration and suppose you know what is the value of infinite dilution, आपको molar conductance निकल जाएगा. Okay. So this equation is called the Ostwald's equation, right? And this might be used to solve numericals. So Vinayak, I am really sorry आप हर दिन बोलते कि numerical solve कराइए, but also today we will be solving only one numerical, that is this, right? From the next class I will try to solve at least 2-3 numericals in the class. Okay. Now look at this. What is this? The equivalent conductance of sodium chloride, hydrochloric acid and sodium acetate at infinite dilution is this much. Calculate the equivalent conductance of acetic acid. Okay. So we have to find the equivalent conductance of CH3COOH. So what I said, Kohlrausch Law is simply all about mathematics. Simple mathematical equation जैसा बनाओ इसको. Now how will I get CH3COH? To get CH3COH from what I have here, can I say that it should be equal to, now this is NaCl, this is HCl and this is CH3COONA, right? So how do I get CH3COH? I will get that by CH3COONA, right? Now what I want to add? I want to add an H, so plus HCl but minus NaCl because I want to remove Na and Cl. Okay, so if this is how you will make CH3COH, the equivalent conductance will also follow something like this. Okay, so this will be equal to the conductance of the sodium acetate plus the conductance of HCl minus the conductance of NaCl. Fine. So if I just put in the values, CH3COO Na का कितना है? It is 910. It is 910, right? Plus HCl का कितना है? Plus 426 minus 126, that is of sodium chloride. Okay. So when you solve this, the value that you will get will be the equivalent conductance of CH3COH. Right? So like this you have to solve the question. Just try to understand कि किस तरह से ये मिलेगा आपको and just minus the other things, right? तो अगर आप इसको बस एक मोलार कंडक्टेंस के फॉर्म में डाल लो, then you will be able to get your answer, right? So that's all about how to solve the questions using the Kohlrausch law. तो आज के CPP में I have given many questions that will be talking about this thing. Okay, so just try to understand क्या हो रहा है यहाँ पे. Simple mathematical way में what we did. If I add this and this, okay, I'll get CH3 COO minus Na plus H plus Cl minus, and because I'm minusing it, तो minus क्या क्या होगा? Na plus minus होगा, Cl minus minus होगा. So this and this will get cancelled off. This and this will get cancelled off. So what is left? What is left is CH3COH. Fine. So that is how we'll do this thing. Okay. So this thing we'll discuss in the next class. Don't worry. So that's all for today. Let me just summarize today's class. We discussed about the Drago's rule. In the next class, I'll also talk about banana bonding, because I've seen many people asking about it. So we'll talk about this thing in the next class. Apart from that, we discussed about the factors affecting the degree of ionization. We talked about the ionic conductance. We talked about the electrolytic conductance and what are the factors on which it depends. We talked about what do we mean by conductance at infinite dilution. Okay, so at infinite dilution, the conductance will be maximum. Then we talked about the Kohlrausch law and how to solve numericals with that. This thing will be talking about that in the next class. Okay, so that's all for today. Now I want all the password users to start answering the questions, and numericals आपके पास बहुत अच्छे आज मिलेंगे, because I've given some tricky questions also in the numerical. Okay, so sorry Vinayak, but most of the questions that are very good will be in the CPP. Okay, so that's why we have the CPP, because in class बहुत कम time होता है, तो we can't solve a lot of questions, but the CPP will have sufficient number of questions. Okay, so that's all for today. Let us meet again on Monday. Till then, good luck.